Welcome to Summarize Science. Have you ever seen one of those sentences where all the letters inside a word are scrambled, but you can still read it perfectly? This paper, See the Text, From Tokenization to Visual Reading, explores why we can do that and why most AI can't. And it proposes a fascinating new way to teach AI to read more like we do. Right now, large language models don't see text. They use a process called tokenization, which breaks words down into smaller, predefined pieces from a dictionary. This diagram on the right shows a huge problem with that. For a simple two-word phrase in the Kyrgyz language, the old method needs to create 11 different tokens, which is very inefficient. In contrast, humans recognize words as whole visual objects. Our brains have a special region called the visual word form area that processes the overall shape and pattern of a word. This is what makes our reading so robust and flexible. The researchers' new method, called SEETOK, imitates this human ability. Instead of breaking text into pieces, it first renders the text into an image, like this. Then, it feeds that image to a multimodal AI, essentially telling it to read what you see. This leverages the AI's existing, powerful ability to recognize text in images, a skill learned from seeing millions of pictures online. And the results are pretty stunning. Table 2 here shows that this visual approach is way more efficient. It requires significantly less computing power, which is measured in teraflops, and is faster to process. This efficiency boost is even more dramatic for less common languages. This chart shows that while it makes English processing over 4 times more efficient, it makes a language like Georgian over 13 times more efficient. This is because it's language agnostic. It doesn't rely on a dictionary that's heavily biased towards English. Besides being faster, SEETOK is also much tougher. Figure 4 shows what happens when you introduce typos, visual distortions, and other noise into the text. The standard text-based AI sees its performance drop significantly. But the vision-based SEETOK model barely flinches, showing a much smaller drop in accuracy. This is the perfect example of that robustness. Just like us, the visual model has a much easier time understanding this typoglycemia example, where the internal letters are scrambled. The standard model gets much more confused because the tokens it's looking for are completely messed up. This even works when you try to combine word parts to make a new word. The vision-based embeddings, shown in blue, are much more consistent and understand that off and line combine to make offline. The text-based method struggles with this kind of composition. So, let's recap the important points. By teaching AI to read text as an image, like a human, the SEETOK method makes language models more efficient, more robust to errors, and fairer to languages from all over the world. So, what could this mean for the future? It points toward AI that is less brittle and computationally expensive. It could also be a major step towards creating more general, human-like models that understand the world through multiple senses, not just fragmented text. This shift from symbolic processing to visual reading could be a quiet revolution in how we build intelligent systems. Thanks for watching Summarize Science.